Brianna, Kylie, if you guys don't remember. So this is Brenna's, and she had the fission theory. Okay, so the fission theory was like the moon was a part of Earth, but it spun at such a high velocity that just like a little thing came out of the Earth, and poof, we have our moon. So, and then it got stuck in our axis, but that kind of failed because when examined in detail, they couldn't find a combination of properties for a spinning proto-Earth that would eject the right kind of proto-moon. So, and then this is a drawing of kind of like the theory of how it went. So it's spinning faster and faster, and you can see how the moon was like, the Earth was stretched and stretched, and all of a sudden, poop, the moon. And the moon, so this is kind of another reason why it kind of was a failed theory. The moon was moving away from the Earth, so reverse that, this is what they thought, sorry, it would become one with the Earth. So if this all kind of went back in time, and then it ended up like that. And then we have Brianna's.
Okay, so we have capture and then concretion. So those are our theories. The capture theory is that the moon was created somewhere in our solar system, and then it just started flying off and got caught into Earth's orbit. But that's not true because the moon is so big, there's no way that the Earth could capture it within its orbital gravitational pull. So that's why it's not true. And it has similar isotope oxygen on the moon and its rocks. And that's only possible as if the moon and Earth were created, were close by. Because on Mars, it's not the same as it would for Earth. So, yeah. And then we have the co-creation, which it's basically where they were both created together, like sisters, twins, sister planets. But that's not true because Earth has abundant of iron, and the moon has very little of that, so it doesn't have as much iron as the Earth does. So, and we found that out because we went on the moon, Apollo 11, in 1969.
Spoiler alert.
So we were able to collect moon rocks, and then we were able to test them and figure them out. So those are all theories, and we had no idea which one was correct until we went to the moon and we got these rocks with Neil, Michael, and Buzz. But only Neil and Buzz were able to go on the moon while Michael stayed in orbit around the moon. So, and then we have a video about that.
She has the right time this time.
Yeah.
Oh, yeah, right.
To study it for the first time doesn't. The impact theory suggests that a collision occurred early in Earth's history, but after most of the moon, it's exactly when solar collided with Earth that Geo are nearly identical. Of the clubhouse they're full of holes as well. There's the capture theory, in which the moon was roped in by Earth's gravitational pull, similar to how Mars captured its two moons, Phobos and Deimos. But these moons were probably just large asteroids that fell into Mars' orbit. This seems like an unlikely scenario for our moon, which is huge and spherical, and it also doesn't account for the similarities in chemistry. Then there's the co-formation theory, which suggests that the moon formed in tandem with the Earth, each morphing out of the same basic materials. But this doesn't explain why the moon lacks iron and is less dense than Earth. The fission theory posits that Earth was spinning so fast in its infancy that our planet could have ejected enough of its own mantle into space to form the moon. Finally, another model theorizes that a nearly identical object to Earth collided with our young planet and went...
Okay, we didn't want to ruin that for the big surprise. Of course. I'm trying.
Okay, what was the other word for it? Not the big whack, but
Oh, giant impact.
giant impact. Just making sure.
There you go. Okay.
So I had the big whack or the giant impact. But this one is way more fun to say. So the big impact theory was put forward by William Hartman in 1975, and because it is theorized that a Mars-like object crashed into Earth in its infancy, and that created all this debris to go in, and it kind of got stuck in Earth's rotational orbit, and it kind of just all came together, and it was, and it created our moon. Okay, bear with me, this is a tricky name to say. Zhu Zhang from the University of Chicago made mass studies of the lunar samples brought back in the 1970s from the Apollo missions. She found that the titanium-50 and Ti-47 ratios were essentially identical to those of Earth's samples from meteorites, and the closest to stand-in colliding body available are quite distinct from those of Earth. So what she's saying is that we, just getting the samples from the rocks, there was, huge, elements that were very similar.
Very similar.
That we
Chemistry.
can't really find anywhere else on any other planet. So it kind of just made more sense. And this is a theory that we have decided is pretty accurate and stuff right now, but it's not for sure because
That's not perfect.
it's not perfect. There's definitely holes in this theory, but right now it's what we have for the accurate description of how the moon was made. But again, further research could be found any day, any second now, and all this could be just one of the other fissions and co-capture. And then I also have a video, kind of gives you more information.
Every time.
Yep, I called it.
It's so frustrating.
And then this is our works cited. Is there any questions that you guys have?
Is there any geological evidence of this happening?
Like the
Geology, minerals, different.
yeah, no, the rocks, they had the same titanium and other titanium 50 and
As the moon and the earth, but what about this object that slammed into
Yeah,
That's kind of one of the
holes.
holes. Yep. And when we look at our planet accretion theory and how the solar system formed, this kind of is an offshoot of that, really. When you think about, when planets formed, there was a cloud of dust and debris, and that all came together to make the planets and moons and the sun. And now we have this impact that blew up some stuff, and then that eventually became the moon. They do know that there's something with the crust on the far side of the moon and the near side of the moon, and I can't remember what it is. I was reading that, I don't know, a year ago or something, and I can't remember what the deal was there. But yeah, you're looking for the chemistry of this Theia,
Yeah.
and they haven't really found it.
So Jupiter has how many moons?
67.
67,
So
yeah.
that happened 67 times to.
No, a lot of Jupiter's moons are probably captured asteroids and comets.
Yeah, my video said that.
Yeah. Where the moon, our moon is so big,
Right,
you know.
all the size of the planet.
Right, it's like, what, a fourth of the diameter of Earth. But yeah, so what about the other big moons?
Yeah.
You know, what about Titan and Europa
Right.
and those guys?
So they don't go into our solar system, that's what the world is trying to say?
No, they do.
The moon structure belongs to